Hello, this is Siddhalingesh Hamgi, Assistant Professor of Physics, Sri K.H. Patil, GFGC Hulkoti. This is my fourth video on gravitation chapter. Today I am going to explain qualitative discussion on applications of artificial satellites and also weightlessness, orbital velocity, escape velocity, application of artificial satellite. First one, weightlessness. My dear students, as you know this word weightlessness, it is a complete or a near complete absence of sensation of the weight. This is also termed 0g, although the more correct term is 0g force. 0g force, it occurs in the absence of any contact force. It is called weightlessness. It is a condition of free fall in which effect of gravity is cancelled by the inertial force resulting from the orbital flight. There is no force of gravity acting on the objects. Next one, weightlessness is in orbital motion of the satellite ಅಲ್ಲಿ ಹೇಗಿರುತ್ತೆ ಅಂತ ನೋಡೋದು. It is a rotating around the earth. As you know, a satellite is revolving around the earth. There is an acceleration which is acting towards the center of the earth. That acceleration is called centripetal acceleration. It is also Earth's acceleration which is balancing the centripetal acceleration. ಅಂದರೆ ಇಲ್ಲಿ g equals to a ಅಂದರೆ ಇಲ್ಲಿ acceleration due to gravity, the Earth's acceleration which is equals to centripetal acceleration. They are equal in magnitude but they are balancing each other. That's why inside the satellite there is no acceleration, which means experienced by the astronaut moving with uniform velocity at any other object in the satellite. Because of the moving with the uniform velocity inside the satellite, he doesn't the object which is not experienced any weight. That's why it is a complete absence of weight inside an orbiting satellite. The materials are persons which experienced a weightlessness. Next one, I am going to orbital velocity. As you know, velocity is sufficient to cause a natural or artificial satellite to remain in orbit is called a orbital velocity. Orbital velocity is the given to orbital satellites so that it may start revolving around the earth, so that it starts revolving around the earth. This is a simple diagram and explaining the orbital velocity. Here capital M is the mass of the earth and small r is the altitude of the satellites from the center of the earth, which is equals to capital R plus h, where r is the radius of the earth, and here force of attraction between earth and the satellite is F is equals to G proportionality constant G m small m product of mass of an earth and the satellite earth and distance between the center of the earth to the center of the satellite, that is r square. Okay, this is the actually force of attraction between the earth and the satellite. To revolve the satellite, centripetal force is required, that is mv naught square by r. The orbit satellite which revolving around the orbit in an orbit, that satellite having centripetal force that is experienced by the earth, that's value is mv naught square by r, and here v naught is the orbital velocity which is provided by gravitational force, which is equals, therefore gmm divided by r square between the earth and the satellite. Next, by balanced this centripetal force and gravitational force. gravitational force is balanced by the both forces, and that is centripetal force is mv naught square by r, and equals to gravitational force is gmm divided by r square. Here small m and small m is get cancelled, and 1 r is get cancelled. V naught square becomes equals to gm by r. Here small r is the altitude of an satellite. It becomes r plus h. You have to substitute in place of r plus h. Now V naught equal to square root of gm by r, and equals to gm by r plus h. But as you know, by gravitational force equation, you have to take gm is equals to gr square. Here g is the acceleration due to gravity, you already know. I have substitute in place of gm gr square and r plus h. Here r square is taking outside from the square root, you get at last r into bracket square root of small g divided by capital R plus h. This is then actually orbital velocity expression. It's very simple to derive. Next, I am going to explain escape velocity. Escape velocity is the minimum velocity that a body must attain to escape the gravitational field of the Earth. Escape velocity, in place of escape velocity is equals to, so this is the expression for the escape velocity, v equals to square root of 2 gm by r. Here v is escape velocity, g is gravitational constant, and m is the mass of an earth, and r is the distance from the center of the earth. Putting the value of gm is equals to r small rg in place of gm you have to substitute small r gr. This is taken by the gravitational equation, and gr you get the equation escape velocity is equals to 2gr. Okay, square root of 2gr. You have to finding the escape velocity of an earth. That's value is 11.2 km per second by this equation. You substitute g value is 9.8 and r value is radius of an earth, which is almost equals to 6.3 into 10 raised to 8 meter. Almost it is 63,78,100 meter, and you get at last after simplification 11.2 km per second. This is an actual escape velocity of an earth. At last, artificial satellite. An artificial satellite and its uses. An artificial satellite is an object that people may have made and launched into orbit using rockets. That's why it is called as an artificial satellites. There are currently over 1,000 active satellites orbiting the Earth. The size, altitude, and design of a satellite depend on its purpose. Size, altitude, and design of a satellite, it depends on its purpose ಇಂದ ಬೇರೆ ಬೇರೆ ಸೈಜು altitude ಡಿಸೈನು ಮಾಡಿರ್ತಾರೆ. ಮೇನ್ ಅಪ್ಲಿಕೇಶನ್ಸ್ ಏನಪ್ಪ ಅಂದರೆ ಕಮ್ಯುನಿಕೇಷನ್ಸಲ್ಲಿ day to day life, dear students, you know the wide applications of the satellites. Without the knowledge, you have already using the satellites applications. First one is communication. Geostationary satellites are used for communication purposes like long distance telephone calls, telex, radio, TV broadcasts, and military systems and communications, okay, etc. Next one, spying. Spying in the sense it is used in the military for spying of enemy troops to locate their positions and movements to their position in military for spying. Next, weather forecasting. This is done by fitting a special instruments and powerful cameras in the satellites, which is monitor various climatic factors such as air pressure, air temperature, and humidity. Next one, collecting the information about our planets and outer space. The artificial satellites are used for collecting information about other planets, outer space, stars, galaxies, and asteroids, etc. At last, collection of information about the natural resources of the Earth. Natural resources of the Earth. Artificial satellites are also used for collecting information about the natural resources of the Earth, like oil wells, underground waters, minerals, natural gas, and coal deposits, etc. These are the today's class topics I have covered. First one is weightlessness and how to derive the expression of orbital velocity, and I have directly given a escape velocity the expression, that is v equals to square root of 2gr, and also finding the value of escape velocity by using the data g and r value, and also at last artificial satellite. What are artificial satellites? What are the main applications of artificial satellites? These are the subject covered today. Thank you, my dear students. Thanks for watching my video and encouraging me. Such a huge encouragement I needed from you. This is